The new design. Let me just update my menu. How to install. So, oh, good morning, everybody. By the way, yeah, it's Monday. Oh, it's Tuesday morning, actually. Yeah, I get my days mixed up. So, in the previous live stream, we were talking about I was talking about the new designs I've been working on, and the previous segment that I was testing was this one, and this new rectangular design. And there's quite an improvement. Let's just put this is the new one, by the way, so I'll put that there a minute. I want to show you the differences. This one has a bit of cogging on it. Now I dismantled the previous two, which I did with the rectangular ones, because I needed the magnets out. So these didn't work so well because I had quite a bit of cogging issues on them. Not too much, not too bad, but so what's the difference between this one and that one? Well, let me just grab my magnet array, see if I can show you the difference. But I'm holding my magnets to drive this under the table. I don't know if I got this right way around. Right, you can see how it moves. We've got a certain amount of thrust on that. Let's move. You can see how it doesn't cog, it doesn't pull back, because we have a certain distance, and you need that distance because the field is in an arc. If you get too close, you get within that arc and then it cogs. So you have to have a certain amount of distance between the magnet array that you want to propel and the actual segment. So that's that particular segment. Right, hang on a minute, I need to put my magnets down a minute, otherwise. So let's move this on out of the way. Put the new one in. Get my magnets again. Now let's see what the difference is. I don't know if I got this orientated the right way around. It might be the wrong way around. Oh yeah, I've got it the wrong way around. Hold on a sec. Yeah, this is number 4, by the way. Right, so yeah, that has definitely got a bit more, because I'm using my thumb as a spacer bit under the table, by the way. So let's just, wow, we can reverse this, by the way. If I flip the magnets I'm driving it with upside down, we should be able to do it from this side. So we can see it move, and I'll flip my drive magnets over. And yeah, right, do this one. Now let's get a bit closer. Let's bring this right up to the table. Right, it might hop a bit. Yeah, it hops a bit. Let's flip it around. Right, I'm holding it about this distance from the tabletop with my finger width at the moment. I need to bring this round, so I'll just do that. I'll just move it up there a bit. Right. Now let's flip it around. I've got the same width. Yeah, it definitely works. We don't have much of a cogging. If I bring it towards it, will push it back even further. So yeah, so you can see that we have quite an improvement. I don't want to be right on the end stop, so let me just move that forward a bit, because I want to show you that it's not got, on the entry point, it's not sticking, unless you get too close. Obviously you need to have the spacing right. So I thought I'd show you this. Now if I put this on the, oops, get away, oops, hang on, it's because I was trying to pick it up with the magnet in my hand. Right, let's just stick this on here a minute. I want to keep it straight, you see. Let's try this at an angle. Oh, I'll go upside down. Right. Now let's try it coming in from this side. Yeah, it's got quite a quick kick on it, which is great. I'm coming in from this side now. Right. It seems to work better one way than the other. I don't know why, because it's a mirror image. The magnets are arranged in a mirror image fashion. I mean, the arc, I'll flip this around because it's easy to see this side. the magnets are arranged in, like I said, the Omega configuration, sort of Omega. If you don't know what the Omega configuration is, let me just try and draw you it. A lot of people don't know what that is, but I suppose I could draw it. But the Omega is basically an ohm symbol, like this. It's not a very good drawing, I know. It's basically that's the Omega, but it's a flattened Omega symbol, so it's more like oh, I've actually got it the wrong way around, haven't I? Yeah, I got it upside down, I think. It's probably scrub that out a minute. So it's more like yeah, like that, sort of upside down, because that's the Omega when it's that way around. So, but it is an upside down Omega symbol, but it is basically that sort of arrangement. But the magnets are right, let's see. So right, so coming underneath, have I got this right around? No. Right. Yeah, we have a considerable amount of thrust on that, which is a good thing. Now, what's interesting, the best way, if this was on a rotary magnet, it would be doing that, right? So what we need to do now is show you how that would, if I can get it, I've got it the wrong way around. So if I can get this like this and bring it in like that, we get a better thrust on it. So basically, let me try and do this. Take this magnet out of my hand a minute, because otherwise it's going to do what it did last time. So if we take the tray out, which is just to guide it really, and try and do it directly on the table. I don't know if I got this right. You see what happens? It'll twist. So that is the reason why I'm using that tray to trying to do this so that we can see. Right, take that around. Right, so if it was rotating, it would work better as well. Because I want it to work on a rotary system, obviously. Let's bring it right on the edge. Right, I don't know if I got this right around. I keep getting mixed up. There we go. It moved. Yeah. Let's try it this way. Oops. Now I'm stuck now because I can't. Let me just try and pull it straight with the magnet. I'm just trying to get it straight with the magnet underneath. Ah, I had it then, just about. Trying to get it straight. Right, okay. I got it upside down. Oh, no, wrong way around. Oops. Yeah, this is why I'm using that tray, so that we don't have these issues. Right, let's try this again. Yeah, we have quite a good thrust on that, and as you can see, I can't pull it out, right? Which is great. Now let's bring this side in. See that? So it is a lot better than the other segments that I was working on before, because if I get one of the other segments that I was working on, which were the these segments, I need the ideally, but if I stick that like that, I'm trying to show you what I mean. I don't know if it'll work, but it's pushing against it a bit. Let me just get the right magnet on. You see, it's pushing it away. Look, let's try and bring it in this side. You see, I've got this repulsion problem. It's dragging it along. You see, I can't get into it. So that's the reason why I decided to go with the other design, because I had this entry and exit drag problem. So if I just hold my magnet right down here and use my finger to, oops, don't stick to the magnet, will you? Right, stick that like that and try and show you what I mean. But yeah, you see I've got entry resistance problems here. And turn the magnet over. You see what I mean? I've got this drag issue at the beginning. So that's why I was remodeling the design. Now obviously with this I use the use these magnets with a rod that goes down the middle, and you can see from here we have the same problem here. Let me try and, you see what I mean? It gets stuck, cogs really bad at the beginning and the exit, you see, and that's why I decided to work on a different layout, because we have this cogging problem. So yeah, I am very, very excited about this new design. It's definitely got a lot more potential, as you can see. Definitely. So anyway, that's an update. I hope you enjoyed it. I'll see you later.